Today, we're going to talk about dimensions. Yes, that's right. The 2D, 3D that you just came up with. At this point, D stands for dimension. And the 0 dimension is point, the 1 dimension is line, the 2 dimensions are plane, the 3 dimensions are space, and the 4 dimensions are space-time. The world we live in, the reality is 4 dimensions. But there's something very interesting. That's the dimension is that it's possible to add. For example, if you add 1 and 2 dimensions, it becomes 3 dimensions. Let me give you one example to understand this. Here's the animation frame. You need multiple pictures to create an animation. And each painting has a fixed time. A 1-second picture is a run, a 2-second picture is stopped, and a 3-second picture is a 3-dimensional space-time mass as the surfaces pile up over time. Then you can understand that 3 dimensions add 1 dimension to the 4 dimensions. That's right. 3 dimensions of space-time, mass of space-time, build up in time. Then let's do it in more detail. Let's understand that 1 dimension plus 1 dimension is a plane. First, 1 dimension is one line, the axis of coordinates. So if we assume that there's only 1 dimension, there's only right and left in that dimension. As soon as you add 1 dimension to this dimension, that is, as soon as you add an axis, you have an up and down. The coordinate plane system is the 2-dimensional system that is made of 1-dimensional, plus 1-dimensional. And as soon as you add 1 more dimension to this, it becomes a 3-dimensional with left, right, up, and back and forth. Did you understand? So let's take a closer look at the first dimension. 1-dimensional, or a line, is made up of a myriad of points. Like a function, there are countless dots on the line, and the dots have to be very small to stand up. For example, if you cut a line in half, the dot on the line should be smaller than the line cut in half. At this point, the line can be cut countless times, so the size of the point continues to decrease accordingly. Then you can't specify the size of the point, which is why the value that cannot be obtained in mathematics is considered false, and the point has no size. So let's come back and talk about dimension. The world we live in is 4 dimensions, space-time. So 5D is 4D plus 1D, so it's adding time to space-time, right? Interpreting the 5th dimension, there is another timeline in space-time that already has 1 timeline. In other words, there is a timeline that is going on in addition to the 4 dimensions that we live in. It can't appear in reality because it's just there. So in order for the backroom to exist, we need a 4-dimensional with another timeline in addition to the 4-dimensional timeline that we have. In other words, the backroom needs 4 dimensions plus 4 dimensions, 8 dimensions, to exist. However, the 4th dimension is judged by the category of our galaxy, not by the category of the entire universe. If you look at the dimension as a category of the whole universe, there are many other galaxies other than our own, which is close to the infinite dimension in which the 4th dimension is constantly existing. However, even the entire universe where galaxies exist is a 4-dimensional space-time, so there are countless 4-dimensional objects in the 4-dimensional space. In conclusion, from the category of the whole universe, the dimensions can become infinitely large. Then the backroom can exist enough. But it's a problem to connect the space-time of the backroom with our space-time. Today, we talked about dimensions. Until the day the backroom is discovered, this video will remain a stepping stone for development. Thank you for watching the video.